Today in geometry, in Chapter 3, Section 4, we are going to talk about finding and using slopes of lines. Okay, slope is denoted by the letter M. It is referred to as the rise over the run. When you're talking about a coordinate plane, the rise has to do with the y-axis and the run has to do with the x-axis. That's why we say that the rise over the run, the formula, is the change in the y value over the change in the x value. The actual formula for that is slope, which is m, equals y2 minus y1 over x2 minus x1. Graphically, you can pick a point on your line and literally count how much it goes up for the rise over how much it goes across. Okay, this is our rise, and then this would be our run. The rise over the run, how much it goes up to how much it goes across. That is the slope, the change in the y over the change in the x. Let's review a few things that we should already know about slopes, but let's just freshen up a little bit. If a line is flat, then its rise must be 0. So the rise on this line is 0. And the run is infinite. We can put any number that we want to in there for it. We'll call 5. So that is 0. So a flat line has a slope of 0. On the other hand, if you have a vertical line, its rise can be any number that we want it to be because it's rising infinitely. So we'll just call that 7 over its run, which is 0. Okay, now this is a problem. If you have 0 in the denominator, then that is undefined. So that is called an undefined slope. Okay, so the red line, it's flat. It has a slope of 0. It's like walking on flat ground, 0 slope. The green line is undefined. It's straight up and down vertical. It would make you have a denominator of 0, which is undefined. If a line rises to the right, then it is said to have a positive slope. It is going up in a positive direction, and then it is going to the right in a positive direction. So if a line rises to the right, its slope must be positive. So on the flip side of that coin, if you have a line that falls to the right, okay, it's going down to the right, its slope must be negative. That means because if you have a point on that line and it's going down in a negative direction, its rise is negative and its run is positive. So you have a negative over a positive, and that will give you a negative slope. These are things that I would look for on a quiz. That a flat line has a slope of 0. A vertical line has an undefined slope. Positive slope rises to the right, and negative slope falls to the right. Those are great quiz questions. Okay, great quiz questions. These 4 things right here. I would write them down on a cheat sheet and know them. Okay, these 4 things, again, this is a hint. Those are great quiz questions. If you have 2 lines, and those 2 lines are parallel on a coordinate plane. Parallel lines are denoted by the little red arrows on them. Okay, if they are parallel, then that means that their slopes must be exactly the same. That means the slope of the first line has got to equal exactly the slope on the second line. Have the same numerator, have the same denominator, the same rise, the same run, and must both either be positive or both be negative. They have to be exactly the same. On the flip side of that, if the lines are perpendicular, then the lines must have opposite reciprocals for their slopes. Remember, perpendicular lines are denoted with the little square in the corner. So if we want to take an example, look at an example of that, what is an opposite reciprocal? Well, one will be positive, one will be negative, and if you have a positive 2/3, then its reciprocal will be 3/2. So they have to have opposite signs, and they have to be reciprocals. Let's apply the slope formula just once real quick just so that you can see how to do it before we make an assignment. If we have 2 points, the first one we'll call 3, 0, and the second one we will have 7, 6. Okay, if we want to know what the slope is between these 2 points, then we're going to use the slope formula. M equals y2 minus y1 over x2 minus x1. Now the key to being successful at doing this is going to be labeling these points correctly. So if this is x1, if we make this 3 x1, then its pair, its corresponding y has to be y1. Now you could make those the 2's if you wanted to, but if you're going to make the first one x2, then the second one has to also be y2. Okay, you just have to maintain consistency. Okay, so if this is going to be x2, then its partner has to be y2. All right, now it's just a matter of substituting them in, the numbers in correctly. y2 is 6 minus y1 is 0 over x2 is 7 minus x1 is 3. Okay, now we're just going to simplify our numerator. 6 minus 0 is 6. 7 minus 3 is 4. You want to keep your slope in fraction form, but reduce it if you can. 6/4 reduces to 3 over 2. Okay, so that's how you apply the formula. What if it asked you what would be the slope of a line that's parallel to it? Well, it would have to be exactly 3 over 2. What would be the slope of a line that was perpendicular to it? Well, the perpendicular slope would have to be negative, because this is positive. So we would have to go negative. The reciprocal is 2 over 3. Okay, so the perpendicular slope is negative 2/3. The parallel slope would be exactly the same, 3 over 2. Let's quickly review what we just put in this lesson. Slope is represented by the letter M. It is known to be the rise over the run. I would write that down. The rise is the change in the y over the change in the x. The formula for that, y2 minus y1 over x2 minus x1. Okay, you need to know that a flat line has 0 slope. A vertical line has undefined slope. A line that rises to the right has positive slope. And a line that falls to the right has negative slope. A line that rises to the right has positive slope. And that falls to the right has negative slope. Parallel lines are denoted by 2 marks just like this. Parallel lines have the same slope. And perpendicular slopes have opposite reciprocals. The slope of one will be the negative reciprocal of the other. Y'all have a good day, and I would know the things on this page in case there might be a quiz on this. Hint, hint.